Hi all, today I'd like to discuss assembly machine code run on STM32 board, and I want to discuss external interrupt trigger. I'm gonna run through the code real fast. So over here we have the reset and clock control equates, general purpose input output pin equates. These are basically pseudo-names to make the code a little bit readable, otherwise we would be dealing with red section of numbers. Following on, alternate function input and output. Then we have equates for external interrupt line 0 and general global interrupts NVIC, the line for activating external interrupt 0. Follow on, we're starting with loading the base address and then masking the offset on the register what we stored in, and then we do adjustments. So we basically turning on peripherals. Once we're done with setting, we save it, and the same concept works for activating the GPIOs. So this is for PC8 and PC9 to make them outputs. Following on, we're loading GPIO-A baseline, and then we want to set up the user's button as an input. This is gonna be our trigger, and then we're adjusting the NVIC interrupt service routine. We altering this external interrupt 0 line in the register NVIC, and then we saving it. Again, this is gonna do, let me read that real fast. Okay, so we're doing alternation function on IO base by setting up these 4 bits of the register, and then in this section we are deciding we are loading interrupt mask register. We unmasking line 0, which is our external interrupt 0. Then we saving it over here by store. Next one in the register called FSR, XT FSR. We deciding if we want the rising or falling edge. So we save that, and then we'll be working with register 4, so we're masking with 0, so we're making sure there's nothing else stored in register. Following down here, we see up there we see in infinite loop, and in external interrupt 1, I always stuck to 0, but it's line 0 we're dealing with, and we're getting external interrupt 1 base address loaded in the register 0, and then we adding the offset for the register for the bit, which by setting it up we actually clearing the flag, as we say. Once the interrupt is triggered, we clear the flag, and then we store it to make it fix, to make it happen. And then we loading the GPIO-C base address into register 0, and over here we adding number 1 and into register 4 and storing it. and then we're shifting every iteration, every time when interrupt happens, we're shifting this one by 8 places to the left, and then the result is stored in register 5. So the register 5 is carrying the output register. So basically what it looks, it's gonna look, let me build it first. Let's build, okay, 0 errors, and then we debug, and let's run the code. Okay, now the processor is clocking nicely, so I have set it up for trigger on falling edge. So when I press, happens nothing. When I release, we get bit 1 high and bit 2, bit 0 high and bit 1 low. So again, press nothing, release. So bit 1 is high and bit 0 is low. And then again, when I release, there's a button debounce. It's not coded, so we get few iteration real fast, but the aim is to go through sequence 0001111000. Okay, so we got this working. I'm gonna upload the code to GitHub. Anyone wants to have a look, feel free. Thanks.